Dear all, welcome to the playlist of Basic Electrical Engineering. In this session, I will be discussing on DC series parallel circuit. In the previous session, I have discussed about what is series circuit and parallel circuit. Now it's a combined circuit that is known as series and parallel circuit. Combined series and parallel circuit. In order to watch the previous video, you can able to click the I button in the particular video. So it will be directing you to particular previous video. Better you can watch series and parallel circuit separately, then come back to this video. That is my suggestion. So moving on to the discussion. First and foremost, let me ask you one thing. What do you mean by series parallel circuit and why it is needed? That's the question I'm asking towards you. Actually, in general or in as far as the practical circuit concerned, alone series and alone parallel, that is very rare. Normally, the circuits are usually made up of combined series and parallel combination. Actually, the electric circuit, which are generally a combination of both series and parallel circuits. Okay, so the combined series and parallel circuits are generally known as series parallel circuit. That's a specialty of series parallel circuit. Okay, so combined series and parallel circuits are generally known as series parallel circuit. Why it is required? Sometimes if the load requirement is high voltage, or sometimes the load requirement is high current, or some otherwise, normally we need high voltage and high current. At that time, we should go for series parallel combination. That is the answer for the question. Why should I go for series parallel circuit? Because to meet the load requirement in such a manner that the load may need high voltage and high current. At that time, we should go for series and parallel combination. If I go for only series, the voltage will be added up. If I go for only for current will be splitting up and it will be added up. Okay, so better go for series parallel connection to satisfy the load requirement. Check the load requirement and do the connection accordingly. Clear? So this is the way why we require series parallel combination. Let us solve some numerical example. As actually you can able to see R1 and R2 both are in parallel. So on the opposite side, we can able to see R3 and R4 that is also in parallel. Now this combination, the first combination, let me mark it as 1. Let me mark it as 1. The second combination, I'll be marking it as 2. You know, the first and second combination. The first combination that is series with the second combination. Both the combinations are in cascaded manner. Now let us solve the problem. The question is, you have been given with one circuit diagram. You need to calculate the total current supplied by the source. How to calculate? So first in the foremost, what you can do? So solve these two combinations. Let us solve these two combinations. That means both are in parallel, no? R1 and R2 are parallel. So we can able to write R1, R2 divided by R1 plus R2. You will be getting one answer. Clear? Okay. In the second combination, you will be getting R3, R4 divided by R3 plus R4. So this is the second combination. So how to calculate R equivalent? You can able to calculate the R equivalent by using the combination. R equivalent is equal to. So first combination is R1, R2. R1, R2 by R1 plus R2. That is serial with another combination. Earlier I have mentioned it as 1 and 2. R3, R4 by R3, R4 by R3 plus R4. Clear? You will be getting the equal resistance. Now what is the question? What is the total current which is supplied by the load? You know that the voltage is equal to 24 volt. It may be battery or DC generator, whatever it may be, 24 volt. Anyway, R equivalent I will be getting from this simplification. R equivalent I will be getting. Therefore, I can calculate the total current supplied by the voltage source is given by V divided by R equivalent. You can apply the Ohm's law. Thus, you will be getting the answer. Now, I will take you the particular answer. Please verify first. Before moving on to the next slide, I request you to work by your own. Then only this will be effective. Okay. All the students, those who are watching this, kindly work out first. Later, you can verify the answer. That could be better. Use the calci appropriately. Okay. So any clarification you can put up in the comment box. I will reply. Okay. Now I am going to display the answer. See, R1 R2 by R1 plus R2, I will be getting the equivalent resistance equal to 71.429 ohm. Second equivalent circuit, I am getting 350 into 200 divided by 350 plus 200. I will be getting 127.27. You know that these two resistors both are in series. Now I will be adding up 71.429 plus 127.27. I will be adding up together. Okay, now let me show you one more thing. The total resistance that is equal to total resistance, or you can call it as equal resistance, that is equal to 198.70 ohm. Now you can apply Ohm's law. I is equal to V by R. Okay, so I is equal to V. Voltage is 24 divided by R is equal to 198.7. Finally, you will be getting the answer as 0.1207 ampere. This is the total current which is flowing through the circuit, or otherwise you can say that this much of current will be supplied by the source. Okay, current is equal to 0.1207 ampere. I hope you have got the correct answer. Okay, thank you. Now I will be discussing about the second type of problem. Here I will be telling the method first, later on you can only solve. So first in the foremost, what you will do is, I need to compute the total current which is applying by the load. I have to calculate. So first in the foremost, I need to calculate R equivalent. How to calculate R equivalent? I will tell you one thing. Here you can able to see R3 and R4. Whether is it in series or parallel? Of course it is series. So you can able to calculate first R3 and R4 combination. R3 and R4 should be computed first. Clear? Now I will be telling you that this R3 R4 combination, the resultant of R3 and R4, that is parallel with R2. So I will be writing it as R2 parallel with R3 plus R4. R3 plus R4. That is also crystal clear. Okay. Now this combination R2 parallel to R3 plus R4, that will be series with the which one? R1. So I'll be writing R1 plus the whole combination. Let me call it as R2 parallel to R3 plus R4. R3 plus R4. This will be the overall resistance, or you can call it as R equivalent. R equivalent. Likewise, you can start from one end. Thereafter, I can use the Ohm's law. I is equal to voltage by R equivalent. Then I will be getting the answer. I request you to calculate first. Later, you can verify the answer. That would be better. So you can put up the answer in the comment box and verify thereafter. I hope my information is clear to you. Yeah, this is the final. This is the way how to solve this problem. Now I am going to show you the answer. You can verify. Okay. Same method can be adopted, or it can be followed throughout the numerical example. Okay. See, first of all, this R3 and R4 is in series. 6 plus 10 is nothing but 10. 6 plus 4 is equal to 10. So this 10 ohm will be parallel with another 10 ohm which is connected in the circuit. See, these two 10 ohm both are in parallel. So 10 into 10 divided by 10 plus 10. Or else I can write in this manner also. 1 by 10 plus 1 by 10 whole to the power minus 1. Or 1, you are taking inverse, no? Same manner. No need to go for in this method. You can directly write R2 into R34 divided by R2 plus R34. Then you will be getting one answer. So that will be series with how much? 7 ohm. See, 7 ohm and finally 5 ohm. 7 plus 5 is nothing but how much? 12. Both are in series. R1 series with the R234. Obviously, I will be getting the answer in this manner. So voltage is equal to 24. R equivalent is equal to 12. So what is the current supplied by the load? Voltage by resistance. Voltage divided by resistance. That is nothing but 2 ampere. 2 ampere is the final ampere. Thus, you can understand that this battery source will provide 2 ampere current. Okay, that's the 2 ampere is the total current which is flowing through the circuit. I think you have got the right answer. Thank you for doing the calculation and following my method. Now I would like to explain one more problem related to series parallel combination. It is also that simple. Let us work out. So please look this particular question. Everybody please go through the particular question. What you will do first? First in the foremost, what you can do is you can solve these two combinations. This can be solved. Both are in parallel. 6 ohm and 3 ohm both are in parallel. How you can able to write? 6 into 3 divided by 6 plus 3. Okay, 6 into 3 divided by 6 plus 3, that is equal to how much? 6 into 3 means 18, 6 plus 3 means 9. The equal resistance will be 2 ohm. Correct? 2 ohm. And these two combinations are in series. 2 and 2 both are series. Okay, 2 ohm and 2 ohm both are in series. And also I would like to look at this combination. This combination is actually in series. So let me modify the diagram. If you want, I will modify. This is 4 ohm. And this I am going to write it as 2 plus 2. 2 plus 2 means 4. Okay, this will be 8. This will be 8 ohm. And this combination I am going to write it as 1 plus 5 means 6. 5 plus 1, 6. All are in ohm only. You write the unit also. Don't forget to write the unit. That is very important. Now what you will do? 6 and 4 both are in parallel. So what is the equal resistance? 6 into 4. 6 into 4 divided by 6 plus 4. So 6 into 4 is nothing but 24. 24 divided by 6 plus 4 means 10. That is equal to 2.4. 2.4. It is very clear. 2.4 ohm. Now let me modify the diagram once again. This is 4 ohm, of course. You are right. So this will be how much? 2.4. And this must be how much? 8 ohm. 8 ohm. You know that from this point to this point you have to consider, say RAB. We can able to say RAB. All are in series. 4 plus 2.4 plus 8. How much it is? 8 plus 4 means 12. 12 plus 2. 2.4 means how much? 4 plus 8 plus 2.4. That is equal to 14.4. 14.4 ohm. So this is the equal resistance. So let me write R equal is equal to 14.4 ohm. 14.4 ohm. Those who are preparing for competitive examination, this will be useful. Especially those who are preparing various entrance examination, these kind of problems will be help you out. Okay, the final answer is 14.4 ohm. Now let us verify our answer is right or not. So I have already worked out. Anyway, I'll be showing you the final answer. 14.4 ohm we have got. Let us check whether it is correct or not. Okay, let me remove whichever I have done the rough work. Yes, you are right. The answer is 14.4 ohm. So this is the way how to compute, how to solve series parallel circuit. So one more question I would like to tell you. Find the current supplied by the source. So I have solved 3 problems. Two to three problems I have solved you and I have explained the methods. So based on the method, you can easily solve this. See what you will do first. I need to calculate current. Current is nothing but voltage by total resistance. Let me call R equivalent. Anyway, voltage is provided 24 volt. I need to compute R equivalent. So 100 ohm. That is okay. Now I wanted to simplify this. First you have to simplify. So two resistors are in parallel. 120 into 40 divided by 120 plus 40. You will be getting the equal resistance. Now three resistors are in parallel. I already explained one shortcut. If you want, you can follow up if you are interested. R1, say for example R4, R5, R6. Now I'll tell you the shortcut. R4 into R5 into R6 divided by, this is a shortcut, R4, R5 plus R5, R6 plus one more term R4, R6. R4, R6. If you do this, directly you will be getting the final answer. Okay. Then you can able to say that 100 ohm, this combination, another combination, and 80 ohm, and also 100 ohm. All are in series finally. So you will be getting, you can make the summation, and definitely you will be getting current. Current is equal to the voltage divided by, voltage is 24 volt divided by R equivalent. So you will be getting the answer. So please put up the answer in the comment box. I will tell you whether the answer is correct or not. Please verify once, because it should be interactive and you need to know how to solve these kind of problems. It may be asked in the university examination or any type of competitive examination. Anyway, it will be worth of watching. I think so. Okay, in my opinion, this will be worth, okay, if you watch this. So in this session, we have discussed what is a series parallel circuit, why series parallel circuits are required, and we have solved 3 to 4 problems regarding series parallel circuit. Okay, what are the different methods to solve this kind of series parallel circuit? And I have given one question for you. Please solve it and put up the answer in the comment box. Let me see whether the answer is right or not. Finally, thank you for watching this video.